of you thought when you read this, when it said, are these quadratic trinomials, and how do you know, that you needed to do something with the numbers and solve it? But then I think we've corrected everybody, and it's really just a yes or no question and telling why. So when you look at these, what's something you need to know before you can answer yes or no?
How to do it.
How to do it, yeah.
Are there two x terms?
What did you say?
Are there two x terms?
Okay, are there two x terms? So that might be something. Where would that fall into when you say two x terms? What do you mean by that?
They're divisible by each other. That's all.
Okay, if they're divisible by each other. What does quadratic mean?
Sorry. We just talked about
There we go.
What does quadratic mean? Anybody know? Is it Corey?
Yes.
Yes. You just said what?
There's two x terms.
You said there's two x terms. And so when we're looking at a quadratic, we're looking at something that typically would have x squared, because we have that squared x term, and we did just change one of those problems. What does it mean to have a trinomial?
Three terms.
Three terms. Excellent. So if I'm looking here, let's just look at trinomials first. What automatically here is not a trinomial?
2x plus 4.
2x plus 4. We have one term here and one term here, so there's only two terms. So we know that that's not a trinomial. We already know the answer to that one is no. What about the other ones? We're looking for quadratic trinomials. Let's look at that first one. 3 cubed plus 3x plus 3.
Yeah.
You think it is? Tell me why.
Because the first number has a exponent, and the second number has a variable, and the third number is by itself.
Okay, so it's you're saying it's a trinomial.
Yep.
Okay. Is it quadratic?
Yep. No. Oh, wait, no.
Yes. It's not.
Yes or no? I'm going to let you keep going.
No.
Uh-huh.
I want to do this now.
So you tell me, do you think it's yes or no? No. Pick somebody to tell me why. Okay? Yeah, come on.
Corey want to go. Oh, yeah.
I know Corey knows.
He's smart.
Okay. Corey,
Smart.
he knows? Go ahead.
Because the first number is supposed to be squared, not cubed.
Okay.
we know you're the
It's
math
supposed to
freak.
be
Okay.
it's just an x, and then the third number is just a number.
You're right. So when we look here, does our x value have a squared here?
No.
No, it does not. And so this is really what we would say is linear. Okay, so this one is not a quadratic trinomial. What about this one?
Yes.
Yes, we know it's a trinomial. I heard a yes back here. Why is it quadratic?
Oh, because the first number is squared.
There you go.
The first one was cubed. No, the first one was cubed.
Okay. How about this one?
No.
It's not a quadratic, but it's a trinomial.
Yeah.
I did too. Say that again.
It's not a quadratic, but it's a trinomial.
Okay, he said it's not a quadratic, but it's a trinomial. What do you guys think about that? Does that make sense?
Yes.
Okay. Why is it not quadratic?
Because the first number is
Cube.
the second term is squared.
Yeah.
Okay. What about if I changed, what is 5 cubed? Anybody know?
5 times 5 times 5.
It's 5 times 5 times 5.
125.
And that's 125. What if I took this and said this was 125 plus 6x squared plus 9?
That's still wrong.
Yeah, it's still wrong.
It's not a quadratic.
Okay. Do we see anything we can combine here?
125 and 9.
Okay. So if I combine 125 and 9, what do I get?
132.
Yeah.
134.
I heard it over here, 134. So then I have 6x squared plus 134. Is that quadratic?
No, because it's a 6 in front of it.
It's not
There's only-
You don't have another, you don't have a middle
Yeah,
number.
you don't.
It is quadratic, it's square, right?
Okay, it's not a
Trinomial.
trinomial. It is quadratic, but we don't have that third term to make it a trinomial. Okay, so somebody recap for me. Why is this not a quadratic trinomial?
It's quadratic, it is quadratic because it has the second exponent right there, but there's not 3 terms.
Okay, good. He said it is quadratic because we have our exponent here of x squared, but it doesn't have 3 terms. Any questions about that? Okay, let's jump down here then. If we solve this problem using this model,
How do you even do it? I thought it was supposed to be 4. I like 2 equations
Like,
like
it's like
that.
that, and then if you had another 25 times 12.
Yeah, then you could solve it by.
okay, okay. Did anybody, how many of you drew the box? Okay, if you don't have the box drawn, go ahead and draw the box so we'll know how to fill it in. So when we look at 25, if I were to break this number down, it's 20 and 5. Is it Cody? Is that right? Thank you. This is the same as 20 plus 5. So we have 2 10s and we have 5 1s. How about 12?
10, 2.
Okay, if I'm going to break it down into my 10s and my 1s, it would be 10 and 2. Okay, so we have 1 10 and 2 1s. Because this right here, if we remember, is in the 10s place and this is in our 1s place. Okay, so we have 1 10 and 2 1s. So then if I move this over here, this is where I'm going to put my 10s. And this is where I put my 1s. And I'm about to, thank you. She's got to correct me. I got to go back to elementary school.
But that's because I wrote it, sorry.
Oh, I was just about to say.
I know, I'm so sorry.
On the inside.
That's okay, it's okay.
Okay.
We're team teachers. I didn't know all this.
So here, we're going to multiply. So we have, what's 20 times 10? 200, we're multiplying. It's okay.
And Lydia has it. She did it the first time.
Perfect. Okay, so tell me then, what goes here?
22. Oh, wait.
40, because again, remember, we're multiplying. 20 times 2 is 40.
And it's 15.
50, because what did we multiply there?
5 and 10.
5 and 10,
And then 10.
And then it's 10.
and then 5 times 2 is 10.
They all like terms. They're all like terms.
They are all like terms. Excellent. So what can we do with like terms? We can combine like terms. So then we have 20 or 200. What's 200 plus 40?
240.
Okay, we got 240. What's 240 plus 50?
290.
And what's 290 plus 10? 300. So our 25 times 12
I want to delete 10.
is equal to 300.
I could have just put that in a calculator.
You probably could have. Yes. But,
Yes.
and so let me tell you why we wanted to work it that way. We need to be able to break down our numbers like that in order now to be able to break down information from algebra. So you need to be able to know what are products, what are 2 things that we multiply together, but also how do those numbers break down in terms of 10s and 1s. So we're going to move on to the next part of the lesson.
When we first start, I want to show you algebra tiles. Have you seen them before?
No.
Okay, they're for you and your partner. You had yes? Who said yes?
Everybody.
A couple said yes. You've seen them?
our young man from Chicago.
Oh, awesome. Have you? Good. And somebody over here says they have. Okay, take them out, and you and your partner are sharing them. So that means I want you both to be using them. Now, today, when I'm just introducing it, we're only going to use one of the colors. For the class today, this color is positive, and this color is negative. And we're not going to use negatives today, because I didn't want to introduce something and use negatives, and because we're doing some different stuff. So you're probably not going to use the red ones. You're probably just going to use the yellow ones. So you can sort them out if you want to. So once you get them out, put them between you so that both of you can share them. This is, look at this little yellow one. What does it say in the middle?
I can't see.
Well, you have one. Look at yours. X squared. It says X squared. So we're going to be using that. And these little ones like this, well, I have one, can't pick it up. This one, what does this have in the middle?
An X.
An X.
Variable.
Oh, good job. Okay. And then look at these little bitty ones right here. One. Now, there is a relationship between the X and the X squared. Do you know what it might be? Can you tell?
X times X.
X times X is X squared. So we're going to talk about that. This little one right here, there's really no relationship. This doesn't have anything to do with the size relating to this X. This is just 1. All right? So what you're going to do is we're going to do this problem with these. And I have, no, I don't need it. No, I don't need it. Okay. I'm not going to use it because it's too little. I have magnetic ones on some of mine. And I was just going to do it, but I think it's too small for the chart. So I'm just going to draw it on my chart. So you'll have to just go with me. So look at our standard first is make sense of problems and persevere in solving them. I didn't give you the academic or the content standard because I don't want you to worry about that right now. I just want you to persevere, stick with this problem and see. I want you to make sense of this problem. See how it relates to anything that you've done before. See how it relates to anything. And then persevere, which means stick to it. All right? Let's read the problem. It's the same one you just copied. Yes, sir? Touch the smartboard, it messes up the computer. When I touch the smartboard, it messes up the computer. Okay. Even when it's off? Mm-hmm. And I just messed up your computer? Like 4 times? Okay, I'm sorry. Okay. I've never heard that when it was off. Okay, well, we're good. We're good. Ready? Thank you for your help. My yard has an area of x squared plus 5x plus 4 square feet. If the width is x plus 2 feet, what is the length? All right? So the first thing we're going to do is we're going to build the area. And when we're using algebra tiles, you're usually going to, well, in this situation, what do we know? What is the first thing we know about this problem?
They're all positive.
They're all positive. So we're going to get this area. And I want you to try to build. What? Yes, it is. Thank you. This is a quadratic trinomial. I want you to get these. Just get these out of your set. So first start there. That's where we'll start. We're getting this. Remember, x squared. Do you have an x squared? Do you have 5 x's somewhere?
No, 5.
Just get those first.
And then we need 4.
I already have the 4.
So yeah, okay.
We're not solving it.
Yes, you are. No, you're going to get the other side. You're going to get what this side
Solved
is.
it already.
What'd you get?
Yeah, so that's what
I can't see it. Okay, yes. We're going to build it, though. We're going to use this to build it.
That's what I was gonna do.
No. Put your phone up. I'm a like Nazi about the phone, okay? I can't stand when people.
I gotta take my mom.
No, you can after we finish. Or text her right now and then put your phone up. Quick. Don't text or anything like I'm dying in here. Okay, thank you. All right, got it? Now, what I'm going to do is set up something you'll see like this. If you, you might want to draw it on your piece of paper in front of you. I'm going to take these pieces right here, which is the what? The width. And I'm going to put it on one side. It doesn't matter which side to me. Doesn't matter which side. So where you want it to go, top or bottom? Top. Top, okay. So I'm going to put x plus 2. So go ahead and do that. I'm going to put x. Here's the long, skinny. Make it long. Here's the x. So go ahead and do that. Are you making fun of my drawing? So stop it. Okay. No. No, draw it. Don't write it. Don't write x plus 2. Draw it. Draw it. Draw the x, and then here's the 2.
Oh, we have to draw this.
Yes, you have to draw the picture.
Oh, okay. So what is that blue thing supposed to be up here?
It's supposed to be the box, like the boxes on the.
Oh, so write the numbers just inside the box.
Just write what I did. Just write what I did.
Draw a rectangle.
So what does this represent in the problem?
The x and the 2 ones.
Yeah.
Right? Oh wait, yeah.
And the width, right?
Numbers, yeah.
All right. What does this represent in the problem?
The square feet of the yard.
Okay, it's the area, right?
Yes, ma'am.
It's the middle part. What are we trying to find out over here?
The length.
The length, which is the other side. How many of you already know the length? You just could do it. I had a couple people. Okay, good. But remember, we're not trying to just solve the problem. We're trying to figure out how to show it with a model. So how are we going to fit our area inside of this so that it fits straight down? We have to keep it lined up to find out what this side would be.
Keep the variables the same.
Okay, so what are we going to put over here? Let's see, we got to keep this lined up like this. Has to be straight lined up. How are we going to figure out the other side? By putting your tiles inside this to show me the area. So go ahead and put your tiles in here. Go ahead and put your tiles inside here. I hear you already. I'm going to do it really quick, but I want you just to be thinking on it. Are you drawing it? Are you drawing it?
Oh, I gotta draw it.
Yes.
I already saw it.
It was drawn. You don't know if you got it right. Well, you didn't know. There you go. There you go. I hear a lot of people saying, I think x squared would go here. Oh, let me pretend I drew that in blue, okay? Somebody said, I think x squared goes here. Why do you think x squared goes here?
Because it's the biggest one.
No.
Say it, whatever you say. Okay, you think it goes for the first term? That's a good idea. That's a good idea. Okay. So if you know this is x squared goes right here. I didn't make that very square, did I? Let me try to make that square. Okay. Y'all bear with me. My drawing is terrible, isn't it? It's all right. All right. If you know this is x squared, which I agree it goes there, what goes here?
The 5.
Look. What times x is x squared? You just told me a while ago. X. So we'll put the x out here. We'll put another x out here.
Hold on,
So go ahead and draw that.
Wait, wouldn't that be x cubed though?
Is it x times x?
X times x.
Yeah, it's okay.
Oh,
That's okay. It's okay. Be patient. X times x is what?
X times x is x squared.
Uh-huh. Now, you see now, how are we going to put these 5 x's inside this box to fit in here? And we can add some more down here if we need to. And see, you think you know, which, I want you to see if you can figure out how you can make this fit what you think you know. If you think you knew how to do it. No, that's what I mean. See if you can make what your answer is fit this one.
What is it? Ones, I guess?
5 x's. Where are we going to put the 5 x's? In the middle, somehow. So can we fit one right here?
Yes.
Okay, so let's put another one right here. Here's one x. Here's another x. Have we used them all up?
No.
Where are we going to put the other ones?
The same box.
Yeah? Can we put them down here?
What other ones are you talking about? I thought you could put 5 X's in the same box.
Well, yeah, you could.
Because it's 5 X.
So we're going by the length of the X. So you can put
Yeah.
4, you can put like 2 more at the bottom. So
Yeah, okay, let's put 2 more down here.
See this for a minute. Some people thought those were like 5.
Oh, I'm sorry. Sorry. That's not an X down there. That's a mistake on my part. So, what if we did this? Have we used up all the
X's, yes.
X's? I did something wrong, didn't I?
It's 5 X.
I meant to put it.
6 plus 6, or should be 4x plus 4? Or?
I did something wrong. Yeah, I copied this wrong.
And then the 4.
I'm so sorry. I copied this wrong. Now, sorry. God, I've done like 4 things wrong already today, and y'all didn't catch it. Okay? So, what if we... No, I meant... Yeah, thank you. Okay. I'm sorry, I apologize. Okay, now, if we... yours won't... Never mind. No, I don't. That would help me, though. Okay, so let's look at this. How can we put this, I'm sorry, I copied this wrong, into this? We're almost there, guys.
6 1.
6 ones, thank you. Now, do that. Sorry.
Well, no, it feels better.
It's okay.
I thought it was. I've been thinking, I'm so lost. I don't even know these poor kids. How do they know? But now I get it.
Well, I had it till I started teaching. No, I've written this lesson over like 4, I keep sending her new versions of it, and so I forgot to change that one, so sorry. I'll probably mess up some of the work time too, but I'll try not to. Okay, now, our whole goal was to build an area in here, and all of our areas today are going to be rectangular, so we're not going to have to worry about those irregular shapes. Our whole goal was to build this with, if I had the right numbers, that would have helped, is to build this in here, but we're still not finished, because is one side x plus 2?
Yeah.
Yes. The other side's got to be x plus something else. So how many, if we keep the line straight, would this be?
X plus 3.
Yeah.
X plus 3? How do you get that?
Just keep the line straight.
Yes. Sorry. So this side would be, and what would this side be?
X plus 2. And then
Yeah, that was my bad. That was my bad. So. Did anybody get this one? This side? Did anybody get this side just by doing it? No. Have you done anything like this before? No. Where you've been given this one in one side and you got the other?
We do it with like,
I don't remember.
regular numbers.
yeah, we do it with numbers, not the boxes.
Okay, but I was wanting to see if you recognize, of course I messed it up so bad you probably didn't. I was wanting to see if you recognize that if you're given this one and you're given another one, this is the kind of problem you're going to do it with in real life. What'd you say?
It's like 7th grade.
You did it, you've done this in 7th grade?
That's like when they start introducing it. It's like old. Like, I don't remember it, but I know I did it somewhere.
Somewhere? Well, because you were using algebra tiles probably. Didn't you say you used algebra tiles?
Coach Ford's class.
Coach Ford's class? I'm going to have to remember this. Okay, stop for a minute. Stop for a minute. Listen, I'm going to show you this one with the thing we did earlier, and then we're going to stop. So what is the length?
X plus. No, it's X plus X plus X. Plus 3.
All right. Now, look at this one. Remember we just did this?
Yeah.
What is one of the sides?
Oh, it'll be X plus 3 and X plus 2.
Okay. But what if we didn't know this yet?
If we don't know, then we can't do it until we find that out.
Yeah, we can. We can. We can. We can.
X and X.
If we didn't know the X plus.
We know what goes in the middle, don't we?
What?
What goes in the middle?
5X.
Okay. So what goes right here? X squared. So that tells us something already. What's that tell us? That this is x, thank you. And do we know what goes here? 6.
Which means it's 3.
Which means what?
It's 3.
That means this is 3. How did he get that?
3 times 3
You
is 6.
multiplying, you multiplying.
Well, he divided, really. He said,
2 divided by, 6 divided.
or he just thought of the multiple. Okay. Now, what do we know goes right here?
X.
2 times x. And what goes here? 3 times x.
Combine like times.
And you combine like terms, and you get
X squared plus 5x.
Wow.
wow.
That's how you know it's right.
That's how you know it's right.
Like a long way.
Okay.
That's the short way.
Well, this one is so you can see it, because I saw very few that could do this problem. Very few. So I want you to see, I want you to try both of these and try your own. Because some of you like your own, but it didn't work so well. So I want you to try this one and try this one with the problems you have. And I'm so sorry I messed up on that last digit, so it's probably, I'm fixing to give you some. So you're going to get some in, I'll take half and you take half. I'm sorry, I was screwed up. Okay, listen to this one. See how you think this is like it. I need to buy trim for my mom's rectangular tablecloth. Trim is that stuff that goes around the edge. You know, the little, I don't know, it might be your grandma's tablecloth, but the little stuff that goes around the edge, it makes it look cute. My mom says the area is x squared plus 4x plus 3. She remembers one side is x plus 3, but can't remember the other side, the other dimension. What would it be? So, is it like this problem or different?
It's just like this.
Okay, you think so? Okay, make sure that you build it. I left you plenty of room. Build it with your tiles and sketch it on here, and then solve it the other way. If you have another way, go with that. Would it help if you drew one of these on your desk? Maybe?
Here, I find it easy.
Well, show me. You need to put all this in here. Oh, you're just going to draw it on there? Okay, that's fine. Guys, would it help you if I drew? I'll throw that away for you in a minute. If I drew one of these on your desk. Okay. See if you can build this area. Go ahead and build it first. Don't do it. Don't draw it. Build it. I mean, leave it. Don't erase it. Go ahead and build it right here. So, how much is the area of the tablecloth?
Oh, x to the second power.
4x plus 3. So find that. Find that in your stuff. Do it together. If you can make one side, what's one side of the, let me see if I can draw it on your desk. Okay. If you can make one side, what was the side? X plus 3. Can you make one side x plus 3? You got to fit all this inside here. So make one side x plus 3 over here with those. Where did I get this number right here?
I'm in bed to build.
Okay, show me. Okay, so does that help you? Okay, so does that help you better when you're solving it?
Yeah, so there should be 2 right here.
Okay. So 2 times 3 is?
Or 6. Yes.
You said 6 and you wrote 3. I hate when that happens. So what goes in that box right here? Look, guys, wait a minute, where am I? How did I get 6 down here? How did I get 6? I got it from here.
Oh, yeah.
So what goes in your box there?
That would be 3.
Why?
Right there.
Okay. So what goes here? There's only one thing that goes there. Then the X won't fit there. It's too long. Put it up there and see.
Yeah.
Look at this. Yes. So x times 3, x plus 3 and x plus 1 equals all of that. Now sketch that. Draw this in your book. I think you almost have it. Well, you do have it. Almost. Close. So what does this tell you one of the sides is? What does this tell you one of the sides is?
It's going to be longer than the other.
Okay, it's going to be x plus 3, right? So you have x. So how would you make that 3?
Like that.
Okay, all of this has to go in here. So that one side is x plus 3, right? Because there's x plus 3. So how can you put all this in here so that one side is x plus 3? So what does that say this side is?
X squared plus 2.
Don't move this. You can't take this out. Okay. What goes right here? What shape fits right there? Look over there. What shape fits right there? Yes. Okay, put that there. Okay. And what shape fits right here?
1.
Okay. So what is this?
X plus 1.
Is that what you got? Draw that.
I need to buy trim for my mom's rectangular tablecloth. My mom says the area is x squared plus 4x plus 3 square inches. She remembers one side is x plus 3 inches but can't remember the other dimension. How long would it be? So what I wrote x squared plus 4x plus 3, and then I wrote the other terms, which was x plus 3. So we know that x plus 3 is going to be on this side, which is the side that she remembers. And we always know x squared is going to be right here. So we pulled out the tiles we pulled out 4 x's and 3 1's, and we organized them until we got a rectangle. And once we got that, then we started to solve the box method. Come on, Carrie.
The other one open. This is hardcore. Let's see. Hold that. Okay. Alright, so then what I did is I put the x plus 1 up there and then the x3 right there. Okay, so you multiply those together and you get x squared, and then you multiply 1 times x and you get 1x. Then you multiply 3x and you get 3x, and then 1 times 3 is 3, and then you combine like terms, so 3x plus 1. So in the end you get 2x plus 4x plus 3, which is the original problem.
Questions or connections? How long is the other side?
X plus 1 feet long.
Hey, if you have a question, if we gave you a question or you have your own, raise your hand. Now.
All right, what standards did this lesson address?
Quadratic trinomials.
Something like that. Is that another?
Keep going.
Oh, we got time?
Yeah.
What do you think it was?
I forgot the answers.
You, with the floof.
Wait for me. Listen, see, when I started, I didn't tell you exactly what standards. And these guys did a really good job of talking about what standards it really helps you do. Have you ever factored quadratic trinomials? Have you ever done that before?
Not like this. No.
Not like this, but have you done it before?
Yes, ma'am.
Yes. You need to see all the ways. Some of you didn't like this, some of you did. I heard some people love this box thing. Who liked that one? The area model, okay? Who of you like the tiles? A couple of people like the tiles. I know you're too cool to raise your hand, thank you. It doesn't matter how you do it. I'm just wanting to see it in a different way. So, okay, go ahead. I'm sorry. Go ahead and ask your question.
How much trim would I need to trim the tablecloth?
Read it really loud so we can hear.
How much trim would I need to trim the tablecloth?
So how much trim do we need to trim the tablecloth?
I don't know, what do you think it is?
Wait, he's got something?
Wouldn't it be the answer?
Yeah.
That we gave? How you talking?
It's x squared plus 4x plus 3. That's the total all the way around. Yes, I think.
Okay, so what you just said, he just said, but we're talking about the trim. Remember, it goes around the edge?
I don't know. What do you think? 4x plus 8 inches.
They said 4x plus 8 inches. Where did
So is it x plus 3? Would that be the term?
Hey, why don't you draw us a square or a box up there? Draw us a rectangle.
We've got another hand up in the back.
Oh, yeah. Okay, what you think?
Wouldn't it have to go all the way around?
Yeah.
Would it?
Yeah, you're trying to.
So what are we going to do? How would we label that tablecloth?
It'd be like the area right there.
Ooh, he just said, which would it be, area or perimeter?
Perimeter.
Okay.
Area of the plot.
Oh, yeah.
Depending.
Wait, we're not finished. How much would it take to trim it? You're right.
No, you gotta add the other axes together.
Yeah.
But wait a minute, he just said it. What did you label in the middle? What is that?
That's the answer right in the middle.
Don't put it in the middle because it makes it look like the area. We don't want to put it in there. Good question. Somebody said, where'd the 4x come from?
Never mind.
Because there's 4 x's.
Where did it come from?
The ones outside of x.
Yeah, the ones in front of the x. Thank you. Some people are saying, is that x to the 4th? Why is it not x to the 4th?
Because we have no x for this.
And you're not multiplying, are you?
No, you're just adding.
You're just adding.
Invisible.
Those are the kind of questions you might get with these kind of standards. What's the trim? Was it area or perimeter?
Perimeter.
Perimeter.
Awesome. Okay. Are you guys, did you get the same thing? Okay, keep going.
Okay.
Can you think of any other uses for algebra tiles in your math class?
No. No.
I mean, you can use it to do like area.
Always think of like exponential form and stuff like that.
One. Just
Okay.
have the mic.
I'm having a brain fart, so.
Did anybody do the last one?
Yes.
No, we didn't get to.
I put the number on the line.
We could do it.
Okay, don't do it right now. It's almost over. Look at the last one. What kind of problem is that?
I'm going to end this as soon as possible.
Quadratic.
Chloe, I'm going to end this as soon as possible, okay?
Well, it's kind of not. Because you know.
number right there.
You can sit down if you want to.
Don't we have to find the last thing?
Uh-huh. And I don't know if y'all got to this yet. I don't think you have. It's called completing the square.
Yeah.
And y'all got it? Okay. This makes completing the square like this. So in a minute, I'm going to let you guys see if you what do you think?
So this is
Okay, well, we're here. Okay, that's okay. Keep going. Anybody else have a question? Don't y'all have a question? Okay, you that ready? Shh.
How does your problem compare to the open?
Read it louder.
How does your problem compare to the open?
How does it compare to that one?
You have a quadratic trinomial and then 2 terms which you have to figure out the total of the problem, I guess.
So they're both quadratic triangles.
that all? Did y'all talk about it?
I don't know, what do you think?
Remember, y'all were supposed to talk.
Oh, you took my line.
Sorry, it was up to y'all, wasn't it? Thank you. Yeah, Cody. Cody. Sorry.
Yeah, Chris.
Jump on that.
Come on, Titanic.
No, they were doing it. So, how does your problem compare to the opening? I agree. Is it different? Is it different anyway? Tell us.
Well, I mean, like, they both have, like, the 2 X's. But, like, the one in the middle is, like, 4 eggs, and the other one's 5 eggs.
That's perfect. That's all I want you to do. I just want you to compare and contrast. When you say, how is it compare, you just say, well, they're the same because, well, one thing, are we talking about tablecloths in both of them?
No.
No. Y'all need to learn the situations and what they're asking for. Because I know some people said if I just gave them the numbers, they could do it, but they didn't like putting it in the story problem. Well, that's what you're going to see. Okay? Anybody else have a question? Okay, let's give them a hand.
No.